Okay, greatest common monomial factor. Remember, that means one term. Monomial factor, we talked about this in class today. Let's go ahead and factor out our greatest common monomial. Okay, we look here. We look at first our coefficients. The biggest factor, the biggest number we can take out of 4 and 24, well, we can take 4. That goes into both numbers. Now we're looking at our exponents. Okay, we have an x to the fourth and x to the third. Well, our greatest exponent is x to the third that we can take out of both. Okay, so we have 4x to the third. We can factor that out. Now what's left over? What can we multiply by 4x to the third to get 4x to the fourth? Okay, well, we know that's just x. Okay, now the second term, we're going to divide that 24x to the third by 4x to the third. Okay, and when we divide, we're going to end up with just a 6. Okay, and we can leave it right there. Now, second one. We see that 8 goes into both numbers, both coefficients, so let's pull out an 8. And we have a y we can pull out, but we can't do a y squared because this one, the biggest, is a y. Now, what do we have left over if we divide out? We have a y left minus a 3. 3 times 8 is 24. And we can stop there. Okay, now let's use that idea to factor these, to solve these, to find our roots. Okay, we see 2x squared plus 8x. We see that we can factor out a monomial there. We can factor out a 2, and we can also factor out an x. Okay, and when we do that, we have an x left over, because x times 2x is 2x squared. And we have a 4 left over. 4 times 2x is 8x. And both of those equal 0. Now back to our core concept, our zero product property. If we set them both equal to 0, 2x equals 0. And x plus 4 equals 0. And solve. Do the opposite operation, divide by 2, so x equals 0. That's one root. Subtract 4, so x equals negative 4. And we have our two roots, x equals 0, x equals negative 4. Alright, let's do part B here. Part B is set up a little differently. Really what we want is everything to be equal to 0. So what we need to do is we need to move that 15n over. If we move that, let me just rewrite this here. 6n squared equals 15n. We want 0 to be on the right side, so let's just go ahead and subtract, since it was a positive, 15n on both sides. When we do that, we're left with 6n squared minus 15n equals 0. Don't forget that equals 0. Okay, that right side, now there's nothing left, so it equals 0. Now we can go ahead and solve. Okay, we need to look for a greatest common factor. We see that 6 doesn't go into 15, so we can't use that, but we do know that 3 goes into both. And also, we can take an n out of both terms there. So if we factor out a 3n, we're left with a 2n, to get back to our 6n squared, minus 5. And those are both equal to 0. Set them both equal and solve, and we'll be done. Okay, 3n equals 0, and 2n minus 5 equals 0. Divide by 3. So we get n equals 0, that's one of our roots. Add 5 on both sides. So we have 2n equals 5. Divide by 2. If we divide by 2 on both sides, we're going to be left with n is equal to, if I squeeze that in there, 5 halves. And those are our two roots. Okay, those are our solutions. If we plugged them in, we would get 0.